I've been on mute this whole time. Life is hard. That's 5 minutes I'm not going to get back. Okay. We'll call that practice. We'll go back. We'll do it again. Do. Good heads up that someone yelled at me after 5 minutes. Oh, what a bummer. Okay, 11 minutes, 15 seconds. So we're doing Chapter 2, Lesson 1, Unit Rates. If you'd like to leave some room here, we're actually going to come back later and do Lesson 2, Complex Numbers. So you might want to leave some space here to write some more for our objective. Our essential question for the next 2 lessons: how are complex fractions related to unit rates? And our first part of notes is just a definition. It's just a ratio that compares 2 quantities with different units is a rate. So that's where we're starting. So pause it if you need to write, because I'm going to go ahead since I'm already 5 minutes behind and Miss Geyer's already mad at me for not having done this. So let's hustle. So we're going to start with a rate. So we're going to say 160 beats. This is an example. BTW. So 160 beats every 2 minutes. And that is a rate because we have 2 distinct units. Our units are different. Which by itself is not very useful to us. But what we do, the math part of this, is we can simplify so the denominator is just 1 unit, and then what we have is a unit rate. It's a special type of rate. So what we would need to do, we want 1 on the bottom, so we're just going to divide. So if we said, what is 160 divided by 2, and that gives us 80. So our unit rate here would be 80 beats per minute, or every 1 minute. And that's our goal. We always want to have 1 as our denominator. That's our unit. Okay, we have denominator, forgot how to spell it, is 1 with an exclamation point. I was given very specific instructions that there needed to be an exclamation point and some enthusiasm. So shout it out loud. The denominator is 1. Okay. That's unit rates. Basically, it's division with words attached to it. So let's do another. For next example, calculate the unit rate if it costs $2 for 8 juice boxes. So you'd write a rate. If it doesn't specify, we just go in order from left to right. So we have $2 on top over 8 boxes. Spelled it wrong. Juice boxes. Okay. So then we want to divide this to make our denominator 1. So what Geyer wrote was divided by 8 and divided by 8. And then 8 divided by 8 would give us 1. And then the math bar we need to do is what is 2 divided by 8. So if we added a couple zeros, so it's a proper fraction, and we did our math, And we would get that 2 divided by 8 is 0.25. So we're left with bad dollar sign. 25 is the cost for one juice box. Or 25 cents per juice box. Oh, I'm supposed to write that. The units rates, in this case since it's money, unit price is 25 cents per juice box. Oof. My E's are out of control today. Alright, that's the first part. Got one more example, and then we're done with this. Because unit rate's pretty easy. Okay. It's a big thing we use them for. And in real life too, once you become an adult and money becomes a thing, we use unit rates to find the better deal. So if you go to HEB, you can look at the price tags, and next to the full price, it will tell you price per ounce or price per pound, and you can use that to make informed consumer decisions. Let's call this example 2, and I can't read what this says. Oh, okay. So it's a little table here. Perfectly straight line. We put bag size on the left and cost on the right. So we have three different bags of something. 40-pound bag. I'm assuming this is ice cream, because I like talking about ice cream. And I would like to get a 40-pound bag of ice cream. I don't know about you. We have 20 pounds for $23.44. Okay. And then an 8-pound bag for $9.88. So what you want to avoid is saying that the best deal is this one that's $9.88 because it's the cheapest of the three, because you also have to consider how much you're getting for that cost. So we need to take all these rates of pounds to dollars and make them so that they're unit rates. So we want to know how much is it for 1 pound. Okay? So our question we would ask ourselves is, which bag has the lowest cost per pound? Which bag has? Chat's picking up and I'm getting distracted. My beard continues to grow. Kids have no class. Cost. Okay. So we want cost per pound. So we want to put cost on top, pounds on the bottom. So if we start at the top here, we have $49 for 40 pounds. Bulbs. And we're just going to divide this by 40. On reality, it's 49 divided by 40. And we're going to cheat a little bit. We're going to assume someone did this work for us, because they did. And 49 divided by 40 is $1.23 per 1 pound. Okay. So what we're looking for is we want to see is anything lower than that. Or is our $49 for 40 pounds our best deal? So we keep going. We go to our next row. We have $23.44 for 20 pounds. And then we would divide both these by 20. So again, we end up with 1 pound on the bottom here. That'll always be the same. I guess I should make these look like 1 since I put an L right next to them. So we would do 23.44 divided by 20. And I don't trust the math, so let me see. Just for fun, we can work this out. 20 goes into 23 once. Bring our decimal up, bring the 4 down. 20 goes into 34 once. 20 again. 14. Bring down the 4. 20 goes into 144 7 times. Okay, I guess she was right. So this does give us about $1.17. And we could keep going a little bit more, but since money only has 2 decimal places, going past 2 decimal places will at most change our answer by 1 cent. And 1 cent usually, hopefully, won't make a difference. Okay. Alright, so we go to our last row. We have a new best answer, $1.17. Now we're just checking our last one. And I can almost guarantee you this won't be the answer unless this is a bad question. So 988 divided by 8 pounds. So we divide top and bottom by 8. Equals still 1 pound on the bottom. And then 988 top in, bottom out. 988 divided by 8 will give us $1.24 per pound. So once we have our 3 answers, then we compare. And we can say the lowest or the cheapest, cost per pound oh, it's dog food. Oh my goodness. I'm reading the answer for the first time. Is the 20-pound bag. 20 bag. I'm not going to put dog food though because that's boring. This is bag of ice cream. If you want to put dog food because you're afraid of Miss Geyer, you can, but I'm going to put ice cream. And then it is the best deal. And that is unit rates. Nothing to it. So once you're done, go take a break, go eat some ice cream, and then we'll come back and do complex fractions. Okay. When am I getting my homework? I don't even know who you are, so I don't know when you're getting your homework. Oh, you're Geyer's kid. Well, then this whole thing was your homework. Hopefully you're writing it as you went, otherwise you're going to have to watch it again. You didn't know. I kept saying that this was what we're doing. Ellis, can you tell the Ulls? I don't want to lie to you all, but how about those Seahawks? Do they have like 15 points through 2 games? Barely beat the 49ers? So good. So good. This is for 7th grade. Please post it. It's posted. Like, you can just hit the rewind button and just watch it again. Started like 11 minutes. Because I can't post it until we're done, and we're only halfway done. Sad face. That was a burp. Alright, 25:50. Oh, I should write this down before I start. Oh my goodness. I'm bad at my job. How do you get the... Oh, there you go. I got you on that. Where's my Hawaii one? Here it is. That's a link for the Cornell Notes paper if you need to download it. Miles. You're welcome. I wouldn't say you're stuck here. trying to promote yourself here. That's my job. There you go. Alright, 31 minutes, 15 seconds. I put it on the stupid wrong page. Oh my goodness. I need a nap. Okay, 31:45. Okay, chapter 2, lesson 1 and 2. This is the lesson 2 part of this. Unit rates, complex numbers. So if you did this on the same page, because you write small, you're just going to add this red part to the title. If you're doing this on a new page, you would only write the part that's in red, plus chapter 2, I guess. The essential question is the same. So if you still have the essential question, don't feel like you have to write it again. So our next part. Lesson 2 is all about complex numbers, and complex numbers are just fractions where the numerator or denominator is also a fraction. So it's just fractions within fractions, which is not as bad as you can imagine it in your mind. My example here. Oh. And then it says, such as 1/2 divided by 2, or 4/3/4. It's a bad job I'm doing today. 3/4. So again, this looks terrible, but it's not that bad. Okay. So example 3, because we're continuing the examples from unit rates, we want to simplify 1/4/2. Okay, and all we're going to do, the real math here that's new, is we're going to rewrite this as a division problem. So we think of it as 1/4 divided by 2. And then instead of writing it as a fraction, we're going to rewrite it like we would write a division problem. So we're going to put 1/4, put it over here, divided by 2. Okay? And then we can do it like we did at the end of the first chapter. We can make this a whole number. So 1/4 divided by 2/1. Anytime you have a whole number, you can write it over 1. And then if we want to make it, because we never actually want to divide fractions, so we change it to a multiplication problem. So we keep the first number the way it is, and we're going to flip division to multiplication. And then we're going to take the reciprocal of our second number. So 2/1 becomes 1/2. And then we're just multiplying fractions, which is just a matter of going straight across. So 1 times 1 is 1, 4 times 2 is 8. So after all that, we get 1/4 divided by 2 equals 1/8. And that's our final answer. So as bad as this looks, it's not so bad, right? It's just a matter of rewriting and then doing stuff we already know how to do. Okay? Okay, what's my next example? So, whoa. Okay, example 4. Do one more of those. 16 divided by 4 over 9. Okay, so we rewrite it as a division problem. So we're going to say this 16 comes first, divided by 4/9. And then we go through the same steps. We make this into a fraction. So we're going to end up with 16 over 1 divided by 4/9. And then we're going to take our fraction, flip it over. So first number stays the same. Division becomes multiplication. And then 4/9 becomes 9 over 4. Wait, hold on. Oh, okay. I'm just looking at it wrong. Okay. So then 2 ways we could do this. We could just multiply our numbers straight across. So 16 times 9 is 144. 4 times 1 is 4. And then we can simplify that to 36. Or since I don't really like dealing with big numbers so much, I'm going to try this again. So I'm going to go back to this step. Okay. Alternate path through history. And I'm going to say 16 and 4, I know I can simplify. Because I simplified it by 4 up here, so I know I can simplify by 4 earlier as well. So 4 divided by 4 is 1. 16 divided by 4 is 4. And then I can multiply these numbers. So 4 times 9 is 36. 1 times 1 is 1. Let's put it there. And we end up with the same answer. So you can simplify at the end, you can simplify at the beginning. You just have to simplify somewhere. Okay? So let's do some word problems. We're almost done. Promise. So example 5. Mark can jog 1 1/3 mile in 1/4 hours. Calculate his speed in miles per hour, which is a unit rate. Okay. So if we write our fraction out, so we have 1 1/3 over, what was it, 1/4. Alright. So this is as bad as it's going to get, because we got a mixed number and we also have 2 fractions. So we're still going to rewrite it. So rewrite. Seems a lot thinner than it was a second ago. Oh, there it is. Division problem. So we have 1 1/3 up top. 1 1/3 divided by 1/4. Okay. So first things first, we can't multiply or divide mixed numbers, so we have to make it an improper fraction. Okay. So we can say, let's just use arrows more. Save space. So 1 1/3, if you remember, where can I do this? I'm going to put it over on the side here. Sorry, Miss Beverage. It's going to be 1 times 3, right? The whole number times the bottom, plus whatever's on top, and that gives us 4 over 3. Divided by, still 1/4. Okay. And then we just change it to multiplication. So our first number stays the same. 4/3. And then division becomes times. And then 1/4, we flip that over to get 4 over 1. So then we just multiply. Nothing really to simplify here. So this becomes 16 up top. 4 times 4. 3 on the bottom. So 16/3, we can rewrite that. We can make that, oops, and this shouldn't be an arrow. That's my bad. Because we're just doing math here, so that's equals. So 16 divided by 3 if we divide that out, to go back to a mixed number, would give us 5 1/3. And then since this is a word problem, there's some units there, so we can say mark. Oops, I was supposed to spell mark with a C, but I think that's incorrect. I spell it with a K. If you want to put a C, because you have a Miss Geyer, you got to follow her rules, you can put a C if you want. So you can say Mark jogs 5 1/3. So what's our units? It's miles per hour. And if you're still confused by that, per just means in 1. So he jogs 5 1/3 miles in 1 hour. It means the same thing. Okay? Per. Not like a cat. Alright, one more. Promise. Example 6. This is expressed as a fraction. Form singular. Alright, so our number is 33 1/3%, which hopefully some of you know by now. If not, that's okay. So this comes with some notes. It says all percents, oops, that S is implied, I guess, are over 100. And then we want to rewrite, because percent means per 100, cent meaning 100. It's like a fun fact for you. So 33 1/3%, we're going to rewrite that as 33 1/3 over 100. Okay, and then we go through the same process that we've been doing. So take our first number and put it first, divided by 100. So then we rewrite our fractions. So 33 times 3 is 99, plus 1 is 100 over 3, divided by 100. That's a whole number, so we just put that over 1. And then we just have to remember not to multiply 100 times 100. We've got to flip our fraction first. So this will become 100 over 3 times 1 over 100. Okay? And now, hopefully, instead of doing 100 times 1, which is 100, and 3 times 100, which is 300, you would know that these hundreds would cancel each other out, and all we're left with is 1 over 3. And we're left with what should be a common fact for us math folks, that 33 1/3% is 1/3. Okay, that's it. That's complex numbers. So stop arguing about turtles, finish your notes, eat some more ice cream, and then you can watch some football. Okay, good night.